As people are coming in, I'm not sure that I'll be able to see the chat, but I was trying to see if people could go ahead and put in the chat like what your role is, because I've heard this audience is kind of a broad audience. So where do you work and what do you do? Just so I can kind of have a sense of who's here today. So if you could just give a quick message about what it is you're doing. Cool. All right. So it looks like we have kind of like a range of people, and there might be some people coming in still from the waiting room. But I'll go ahead and get started. So today, I'll first kind of recognize my funding sources, and then I'll introduce myself a little more and talk a little bit what we're going to talk about today. So I first want to start off by saying that today I'm going to be talking a lot about DLD, or developmental language disorder. It's kind of my area of research interest and what I work on mostly. And just a quick mention that last Friday was the DLD Awareness Day here in actually internationally. So we did a couple of things here in town to recognize that day. So this year's theme was Speak Up for DLD. So I wanted to make a quick mention of that. So, make sure my slides work. Okay, cool. So the research I'm going to be talking about today is mostly associated with the National AI Institute for Exceptional Education, which is jointly funded by IES, the Institute for Educational Sciences, and the National Science Foundation. And I'm going to talk a little bit about our overall goals and structure of the organization, but just to recognize the funding up front here. So thank you all for quickly doing some introductions in the chat there. I want to introduce myself. So my name is Alison Hendricks, and I'm an associate professor in the Department of Communicative Disorders and Sciences at UB. And to give you a little bit about my background, so I am currently here at UB and I direct the UB Language Learning Lab. We are mostly working with students who have developmental language disorder and or dyslexia, and usually in the early elementary school kind of age group. So here you can have, we did one of my students put up the board in the hallway to recognize DLD Day last week. So here are some of my lab members there showing that. And, we've been using like low-tech techniques for many years to be able to better identify children who are having difficulty with language or literacy. And then a couple of years ago, someone came to me, Jin Jung Chung, came to me and said, hey, we're interested in AI technology and how we can maybe apply AI technology to the kind of speech and language space. And so that's my background in AI is mostly through these collaborations with them. I'm on the language science team. My expertise is in language science. But I've learned a lot through these collaborations with the computer scientists, and that's what I'm going to be talking about today. So we have now kind of expanded into artificial intelligence and gone out into the community to demonstrate some of those things with our students, and also to kind of show our research to another kind of community. I also teach at UB, and I teach undergraduate students and graduate students. And I wanted to start off by talking about how we can use large language models or things like GPT in the classroom, and recognize at the same time their strengths as well as the limitations. So just to give an idea of what I am doing with AI in the classroom, these are probably similar to things that you might have run across using things like GPT. But large language models can help us to create materials for student learning. So I teach phonetics, which is a course for undergraduate students who are learning how to transcribe what people say using the International Phonetic Alphabet. And I have to have lots of examples to be able to do this kind of teaching. And oftentimes I need examples that meet certain criteria. So for example, earlier this year, I was trying to come up with some examples for my students. I think these ones I might have actually been looking for items to go on their test, their first exam that they did. But the students at that point had only learned vowels and consonants, stop consonants. So stop consonants, things like p, t, k, but they hadn't learned anything like a nasal or a fricative sound like a s or sh kind of sound. So I needed words that kind of met those criteria to be able to meet my own learning objectives. And so I went to GPT. Let's see how this is going to work for me. Okay. And I said, okay, can you give me a set of words that have, only vowels and stop consonants, right? And I said I wanted to be 1 to 2 syllables long. First, it gave me just 1 syllables because they're easier. And then it gave me a longer set of words. So, and it took several iterations to be able to come up with the final set of words that were helpful for me. And one thing that you can notice, and a lot of times we sometimes say that the large language models will like hallucinate. I like to call these errors instead, because I'm very concerned kind of on a larger side of things. I'm very concerned about the idea of using cognitive verbs to describe artificial intelligence and large language models. So they don't hallucinate because they don't think. So they instead just make errors, right? And so there are often errors, and those errors need expertise to be able to evaluate the accuracy, right? So one of the themes that I'm going to be talking about throughout is trying to see AI as being a tool that we can use that really serves our purposes rather than being something that kind of exists outside of the area of content expertise, right? So it's something that we can use to meet our goals. And we need to have our own content expertise to be able to evaluate how good it is, right? So I think I kind of pulled these from multiple things here, right? But at one point it started giving me ends, it started giving me TH sounds, right? And I would kind of instead go back and say like TH is not a stop, right? And it would say like, you're right again, here's an updated list, right? And then it would give me things like that might include an N sound, right? Which is also not allowed in this context here, right? And so on one hand, this is kind of frustrating for me to be able to try to get what I want out of it. But I think it also kind of provides an opportunity to use these types of errors in the large language models as a learning opportunity for students, right? So because large language models are imperfect, they often will produce things that are just not correct, right? We can actually use or leverage those errors as a learning opportunity. So one of the things I'm planning on doing in my class is to be able to, or to use those types of errors and have students actually be the ones that can evaluate whether or not it's correct or not. I think that'd be helpful for a couple of reasons. One is that it can show the students that the current large language models are not good enough, right? So they have to do their own learning. I find sometimes that students think like, well, I'm not going to need this because like, in a little while, like it's all going to be done by artificial intelligence, right? So there is like an overestimation of the power of artificial intelligence sometimes among students. And I think it can show them the kind of limitations that there are in using those types of tools. But it also shows them that they need to have their own information, their own content knowledge to be able to say like, yes, this was correct or this was incorrect. So those are the types of things that I'm trying to incorporate right now into my teaching in higher education to be able to both recognize the power. I know I use it in my teaching, but also to use those errors as a way of meeting our pedagogical goals. So I wanted to quickly talk about higher education. I know a lot of people are interested in that here, but my main area of focus and my main area of research is on education in the early elementary school period. And so that's what I'm going to talk mostly about today. So we know that many students in our schools have some kind of difficulty as it's related to speech and language. So this is kind of, this is older data. It was from a couple of years ago. But you can see these are students who are currently identified under IDEA and are receiving services for one of the kind of set disabilities in those categories. So we have things like specific learning disabilities, speech or language impairments, which sometimes if you think about speech and language pathology, you think about that one category. But students in many of these categories also have difficulties with speech and language. So students with autism may have difficulty with pragmatic language. Students with specific learning disabilities are maybe in the dyslexia category, which is also kind of a speech and language related kind of skill, right? And so we have calculated that about 80% of children with specific language disabilities struggle with literacy and language. Then we have the category of speech and language impairment, and about half of the children in this other health impairment may have developmental language disorder, right? So there are many children in our schools who need supports in the area of speech and language. But at the same time, even though we have so many students who need those types of supports, there are currently only 60,900 speech language pathologists in the United States. So what that means is that we have a real mismatch between the number of students who require speech and language services and the clinicians who are experts in speech and language to be able to provide those services. And so this was kind of the problem here that they came to me and said, like, what can we do here? Maybe is artificial intelligence a way that we can try to address this challenge, right? Can we try to scale up the types of services that we're providing? Can we try to do things like reducing the burden on speech language pathologists in like recording data, in report writing, in finding materials that would be appropriate for students so that they can spend their time providing high quality instruction to students, right? And so the goal with this was not to say like, hey, how can we build like an SLP robot, right? But to say, how can we make it so that speech language pathologists can be spending their time providing the services that they are really highly trained to do. So I wasn't sure kind of what the background of the audience would be. So here's a little bit of information about how do speech and language services currently work most of the time in most of the schools in the US. So what happens usually right now is that there are groups of students and usually what is required is that students need to have somebody notice that there's some kind of problem going on. So this student maybe isn't understanding what's happening in class. They're not speaking the way that we might expect them to. Maybe they're using shorter sentences. Maybe they are having difficulty with reading, right? There's usually this ad hoc referral. We do have some screening, and screening is actually like an area that I'm really interested in my low-tech kind of approaches. But oftentimes what's happening is that students will get into like second, third grade, right? And then they are struggling with reading. And then people are like, I don't know what's going on here, right? And then they have an ad hoc referral to a speech language pathologist who will then do a full battery of testing, which will determine the student's eligibility. The students get an individualized education plan, and then have some kind of services from SLPs and from teachers, right? And because we have this mismatch right now between the number of students who require those types of services in schools and the number of SLPs who can provide those services, and with the scheduling problems and things like that, we often get kind of mixed group multi-target interventions, right? And there's actually some research to show that those kinds of mixed groups are beneficial, but we're not really right now able to create individualized instructions for all students. It's just not necessarily feasible to be able to do that every single session for every single student, right? And so it's a really complex problem for speech language pathologists to try to solve. So the current situation is that it creates what we call a vicious cycle, right? So we currently have a shortage of SLPs in the United States. And because we have a shortage of SLPs, we're not really able to do a lot of ongoing universal screening. We do have in New York State, but not in all states, we have like kindergarten entry screening for all students. Those tend to be really broad screeners that are trying to target a number of goals, right? It'll target overall language as well as like gross motor kinds of things, right? So those are kind of broad. And they're usually done one time. So even in New York State where we have pretty good screening, it's generally one time. One-time screenings are not perfect because we also might have some overlap between things like bilingualism or background knowledge and the students' abilities, right? And so we can't do kind of ongoing universal screening of students because we have this shortage of SLPs. What that means is that sometimes students are either misidentified or identified later. That means that by that time, they require more intensive or more frequent services, which then leads to more of this increase in the shortage of SLPs. Then we have to have kind of like this larger group interventions rather than individualized interventions. They can have lower academic performance, which means they require more services, and we kind of have this like ongoing cycle, right? And so the goal of the National AI Institute for Exceptional Education at UB is try to intervene at one or more of the places on this vicious cycle to try to move us to a place where we can create technologies that would help us to address the students' needs. Basically, it's not necessarily to center on the shortage of SLPs, but to address the students' needs. So this is a large collaboration across 9 universities in the U.S. It's based here at the University at Buffalo, but we have 30 researchers from 9 institutions that are all kind of working on this project. So we have 2 main AI solutions that we're working on, and I'm not going to talk too much about the whole like institute structure, but we are working on screening and we're working on interventions, basically. And I also, I'm going to talk about a couple of projects that I'm involved with, but I'm not necessarily going to talk about everything that everybody's working on in this large group. I did want to highlight the fact that I think that it's a challenge to work in a large group like this. It's a challenge to work across geographical distances as well as across like field-based differences. So understanding exactly what the terminology means when we talk about coding, for example, in language research, we're usually talking about like flagging sentences as like grammatical or ungrammatical, or including a feature or not including a feature. When computer scientists talk about coding, they're usually talking about like writing computer code. And so even though sometimes we're using the same words, we're not necessarily understanding each other. So it's been a bit of a challenge to try to figure out how we can communicate across those kinds of geographical and like field-based barriers. And one of the things that I think is so important about this type of work is that you do have collaboration between people who are in artificial intelligence as well as content experts, right? And so I'm going to highlight like why that matters, like one concrete example to show why it matters that we have both content experts and computer scientists or others involved. Okay. So one of the things that we are working on is spoken language understanding or automated speech recognition. So in order to know how well the student is doing and how well they are progressing in their speech and language skills, we would like to be able to use automated speech recognition. I know that many of us have trained whole groups of undergraduate students in the lab to be able to transcribe language samples from students or what they're saying in a conversation. And for speech language pathologists in schools, this is really a big ask. So to be able to collect ongoing language samples and to transcribe them and code them is really difficult and can be quite a burden. And so if we could try to have automated speech recognition to help us out with that task, that would be really helpful. But one of the things that we have noticed with automated speech recognition is that computer scientists and speech language pathologists may have different goals for what their endpoint looks like. So here's an example. So here is a conversation that is pulled from an online database. And this is a conversation between a researcher or investigator and a child who is 5 years old. So you can see where it says CHI, that's the child's utterances, and INV, that's the investigator's utterances. So they're having this conversation. So the child says, and then Corey can be the dog and I can be the person. the investigator says someone pretends they're a dog. The child says, yeah, Corey is the dog. And then you can't really hear what they're saying at that point. And so if you were thinking kind of from a computer science angle about what does good automated speech recognition look like, it's really dependent on the task that you're trying to do. So if your task is to be able to, for example, dictate your emails or to write a paper, like to speech to text, write a paper that you're writing, you don't want this kind of repetition, this disfluency in here, right? And you also would like it to definitely like make a choice as to what the word is that they're trying to say, right? You don't necessarily want your email to say like XXX, like I didn't know what you said right there, right? And so the goal from, if your task is speech to text transcription for like writing emails, for example, your goal or your best case scenario is to have an error-free output, meaning you've removed all the errors from the transcript. If, however, your goal is to understand the student's speech and language skills, then this information here, these repetitions, the hesitations, the pauses, the unintelligible speech, that is all useful information for speech language pathologists to know what is the level of effort that this child is putting into being able to produce this utterance, right? Was it easy for them to say it? It just kind of like came to them quickly, or did they put a lot of effort into trying to produce that utterance? And so this information here is really informative if we're looking at the goal of identifying which students have speech and language difficulties, right? So we want to preserve all those errors, hesitations, and false starts. And so my point with this was to try to show that we all have to come from the point of view that knowing the content information, that these hesitations and pauses are meaningful and can be useful for identifying students with speech and language difficulties. And then collaborate with the computer scientists to be able to design a system that's going to try to achieve those goals, right? And so with all of that in mind, I wanted to spend a little bit of time to talk about some of the projects that we've been working on to use AI to create some formal and informal learning opportunities for students. Okay, so this is actually a picture from one of the supply rooms at our clinic here for the UB Audiology and Speech Language Pathology Clinic here at UB. And you can see that there are often a lot of these kind of like static materials that SLPs use when they are trying to design an intervention. And you can't quite see in all this picture, but there are a lot of these are for speech, so for like sound production, but there are also ones for language and for some literacy skills as well. And it's kind of typical that, you often see these really colorful materials that people are using in their therapy. In order to get lots of repetitions of the number of items in a therapy session, sometimes people use these kinds for like a drill-based kind of activity, right? And so they are purchased commercial products that are intended to match students' needs. But we were interested in trying to create our own materials for speech language pathologists that can be informed by the research base that we have on trying to improve student speech outcomes, as well as being able to create personalized and individualized materials for students. And I'll show you what that means in a second here. So research has shown that students benefit from what's called minimal pair contrast therapy. So in working with students to improve their speech production, it's helpful if you show them pairs of words that differ in one or more of the phonetic, where one sound differs in one or more of the phonetic attributes. So consonants are typically described in terms of their place of articulation, so where in the mouth that they produced, whether or not they're voiced or unvoiced. So we have a s versus a z sound, one is voiced and one is unvoiced. And then the manner of production. So how do we produce that sound? Is there a total blockage in the mouth, or do we let some of the air flow through, and so on, right? And this is all described in like the International Phonetic Alphabet, which I showed you earlier with the teaching my students those types of things. So there are some students that will benefit from having a minimal pair like this one, where they are the two sounds share two of the features, but they differ in one of the features, right? So man, for example, is a minimal pair with fan because they have different places of articulation um, and they have voicing and the manner is actually so they differ in manner. Yeah, sorry. So the no's and yeses here means that the no means they're not different and yes means they are different. You could quibble about that. That one there for, yeah. This example was created by one of our computer scientists. I might argue about the labial. That's okay. So we created a system using large language models and AI image generation to create flashcards for students that meet some of these needs. So, and we wanted to see sounds that are, we wanted to find, for example, in this first one here, we want maximally contrasted sounds, so sounds that differ in all three of these features that have differ at the initial sounds. We want the difference to be in that first sound in leak and peak. It's the first sound that's different. But we want, and we want one of those sounds to be an L sound, right? So for this student, for example, I'm working on that L sound and I want to create some minimal pair flashcards that have different place, manner, and voicing. So they're maximally distinct. And they, the difference is in the first place there, right? And so we can create pairs of words like leak and peak to be able to help that student. We could also say we want to have those that difference there to be in the final position. So bowl and bow differ in the final position sound. The L at the end is different in bowl versus bow. And so you can see there that they differ in their place of articulation, as well as they share their voicing, and they also differ in their manner of production. So one is a vowel and one is a consonant. And in the last example there, we have rake and cake, in which we want to have the initial sound be an R, right? And so to show you these here, we actually have a way in our actual systems that are kind of demo systems that work, where we can change whether or not the images are more cartoon-like or more photorealistic, or whether or not they are, include more color or less color. And so with that, we can move from using these kind of like static like decks of cards to try to individualize them for students. So one thing that happens is that some of the materials that are available are like they look young for students, right? And so they'll have kind of cartoony characters, but you may be working with a student who is in 5th grade and you want the materials to look kind of age appropriate for the student, even though the content would be maybe at a lower level. And so being able to toggle some of those features is one way in which we can create those kind of individualized materials. It's also another way that we're kind of trying to work on ways in which we can create more like culturally relevant materials for students. And it's kind of a hot debate within our institute for how do we do that in a way that is not potentially stereotyping, and also making sure that students are all exposed to a wide range of materials. So we want to individualize and tailor materials for students, but we don't want all students then to basically be like isolated and like these are the materials for me, and they never see other students' materials as well. So we think that it's important to think about being really thoughtful about what does individualization do to the learning experience, right? So we want all students to have kind of like a base shared information, even though they're getting individualized materials. Okay. Okay. So another project, that's a better word, project that we're working on is trying to create modified text that can try to meet students' needs where they're at. So this was kind of inspired by some research that I did a couple of years ago. We had students who were screened and tested in 2nd grade. So the time point 0 here on this chart, which I'm going to explain to you, is grade 2. And so they were identified as having DLD, so developmental language disorder or language difficulties, and dyslexia, both DLD and dyslexia, or they're typically developing students. So we had those 4 groups of students. And what we looked at was for students who are identified as being in our DLD group or dyslexia group, both group and typically developing, what do their school testing scores? So this is the MAP test that is given in schools. What does that look like across grades 2 through 4, right? So we're looking at the academic outcomes or the academic implications for these students who are identified as having language and literacy difficulties. And what we found was that, perhaps not surprisingly, that the students who have dyslexia, the students who have language difficulties, they struggle in reading, right? And that's not necessarily that surprising. What is surprising is that the both group is so substantially different than the dyslexia only group. And so I could talk about that if people are interested. But the takeaway here is that students with language and literacy skills struggle in reading on school standardized assessments. That's not necessarily all that surprising. What is surprising, though, is that those students also struggle in math, right? And so those students struggle across the curriculum. And so we like to say that language is everywhere and it touches everything, right? So students who have difficulty in understanding oral language, so understanding communication, have difficulty in math. And so we're kind of trying to figure out, like, why would that be the case, right? So is that due to some kind of underlying learning difficulties? Or is this difficulty in like accessing the academic content through instruction? Is it that we are testing math through language? Is it that we are teaching math through language? Both of which are true, right? And so I know I have a 3rd grader who's just coming home with more math, and the math really like ratcheted up in 3rd grade. And it has so much language in it. And it's like the first thing that I notice is that like she has to write a sentence to explain the answer. Lots of word problems, right? And so there's lots and lots and lots of language in math instruction and in math assessment as well. And so we're trying to figure out here, how can we try to, one, address this learning question that we have, and also to be able to provide materials to students that can try to maybe get them access to the curriculum in other areas, okay? So we have been using AI to try to develop individualized texts for students. We've tested out doing 0-shot, like no training prompting. We've looked at few-shot, which is kind of like limited training based on human coding. Iterative few-shot, which was our best one, which is repeated short training prompting. And so what we've done is we have looked at science and we've looked at math questions so far, and we're currently working on longer kind of informational texts. And we try to see, can we change the reading level of these questions in math? And we're also kind of like separately, I'm not going to show this here, but we're also looking at, can we change, for example, just the grammar and keep the vocabulary the same? Can we change just the vocabulary and keep the grammar the same? And we also are looking at like decodability, or how similar the writing is to the oral language. Because we know, for example, kids with dyslexia may have more difficulty with that like oral language to written text correspondence, whereas like children with developmental language disorder have difficulty mostly in like grammar and like syntax. And so we're trying to see if we can change it, but preserve the difficulty in one area and make it easier in another area. So this is kind of an example here at the bottom, and I want to just kind of show you what we are doing right now. So we are trying to see like the original here. This was originally like a grade 5 kind of question. And then after we have our iterative few-shot prompting, we can get the reading level down to like a grade 4. So we're able to drop the reading level down to 1 grade. We can actually go further. We're trying also to try to not go too far and not remove all the difficulty from the sentence, and just keep it right in that like kind of area just outside of reach for the students, right? Kind of the zone of proximal development is what we're thinking of, and try to keep these texts just outside of reach for the students. Eventually what we'll do is we'll try to like vary that. So we'll try to see like, does it help if I remove the barrier completely? and kind of make it super simple for students? Or can I scale it up over time? And those are kind of the questions that we're kind of looking at. But that gives you a sense of like the types of things that I think that AI can do going forward, but also that it's important that we ask the important questions of saying like, is it good to just give kids very simplified texts? Or is it better to be able to give them slightly simplified texts? And those are important questions that I don't think that our field of speech language pathology or language science have really been able to really answer yet. But I think that AI can give us the materials to be able to answer those types of questions. So the last project that I wanted to highlight here to show the promise of AI is some work that's being done by my PhD student, Sonia Islamnisha, as well as an undergraduate student who is an intern in our lab over the summer, Iman Salim. And what they've been working on is trying to use AI image generation, kind of like I showed you for the flashcards, for creating materials for progress monitoring for students. So we know that we want to confidently say like this student has met their goal and we can go on to the next goal, right? We want to, as soon as possible, to move that child on to something more difficult so we can maximize and be really efficient with their learning time. So progress monitoring helps educational professionals track students' growth and know whether the child is ready for something harder. And so we're going to create a progress monitoring tool that captures their progress over time and can potentially give the educational professionals the like quick information that it's ready to move, their child's ready to move on to something else. So here's kind of just like a diagram of the tool. And the idea is that we can have a certain number of sessions, and then we would do some progress monitoring using a picture description task. And then we would use that information to adjust to the student's needs, right? So to say, all right, we can continue with this topic, or maybe let's move on to a new topic, let's slow down, anything like that. So I wanted to show you some of the images that we have been working on, and they are like in the AI world, I'd say like they are very old, which means they're like from a month ago. I think we're able to do a lot better image generation now that we've been working with some other models. So here's some of the challenges. So if you look at these three pictures here, if I were to tell you and say something like, can you tell me a story about this picture? You could take 1 second and think, what are the types of things that you might say if you see these pictures? Try to say, tell me a story about these pictures. I think one thing you might say is you kind of describe each individual character, right? You say, well, there's a girl sitting there and she's playing with crayons, or there's a teacher in the background and she is looking at some of the students. So you'd get relatively simple sentences from this type of picture. The other thing is that when we found these ones were created with DALL-E. These ones are created with DALL-E 3. We originally used FreePic and then we used DALL-E 3, and now we're using some other types of models. And what we tend to find is that they're very busy. They include a lot of repetitive actions. They focus on certain characters or objects, so they tend to centralize one thing in the image, and it's difficult to kind of get a full story out of this type of picture. And sometimes we would ask for specific things that just were not in the prompt at all, right? So if you've worked with any of these models, we would say we want to have 4 actions happening in this picture. We would say we want to have a girl flying a kite, and then she would do this. We tell the whole story, and then only like 2 out of 3 of the things were even in the picture. So sometimes it just drops out things from the image, right? Since then, we have moved on to trying to use series of images to try to get students to tell stories. So here's an example of some of the series of images that we've been working on. So see if you might tell a story based on this image, these set of images here. So we were initially really happy with this because we thought, oh, okay, we're getting much closer to being able to tell a story and a sequence of events, right? We're interested in having students tell stories and sequences because tense and agreement are really good markers of speech and language disorders, right? So kids with developmental language disorders struggle in the areas of grammar and morphosyntax, in particular subject-verb agreement, or uh, it's an area of difficulty, right? So we were trying to get stories and verbs and many different verb combinations from them. And so we were initially really happy with this. We said these are kids, they're going to the beach, and then you can get some sequencing, and then they build a sand castle, and then there's a problem source, right? We always identified that there had to be a problem source. It was started to rain, and they were worried. Maybe we got some cognitive verbs out of here, right? And then they prepared for the storm. They found some shelter, and then finally at the end, they had a nice day. Something like that, right? So you're getting a lot more language out of these kind of sequence of stories than we were able to get with those first pictures there. Now, one thing is that I think it's always really fascinating how our brains play tricks on us with the AI generated images. When you just look at it first, you're like, oh, these are kind of similar images. But if you look even like carefully at all, there is no continuity of the characters, right? So this girl with the braid, she's got one braid, then she's got two braids. It's like a totally different girl from picture to picture, right? So it includes a girl with a braid, but it's different kids throughout the pictures, right? And so we are also trying to work on how can we have consistency across the images, right? And that's another place where collaborating with computer scientists has been really helpful. So that turns out to be quite difficult to be able to have consistency of images of characters across images. And so they're working with us to try to come up with solutions to try to create these types of materials, right? So those are kind of just a couple of the things that we are working on in this space. To my goal in doing that was to try to highlight and show some of the current state of this research, and also to highlight the importance of talking across fields to be able to address a problem. So we're hoping to kind of move from that vicious cycle to what we describe as being the virtuous cycle. So we can, for example, use human-centered design AI principles, right? So including people in the development of these kind of AI technologies. We can try to implement our solutions in schools and deploy them to make an impact. And then when we do that, we can answer some of the questions that as learning scientists we have, some of those questions that I have about like, what is the right level of difficulty for students, right? What is the exact, oftentimes we write goals, like a kid will achieve 80% accuracy on this target. And then you say, okay, the kid has met that target. I'm going to go to the next target. But we don't have a ton of research showing us that that is the exact optimal level, right? And so by having these kind of flexible tools, we can try to answer some of the research questions that we have in language science in a quicker or more efficient way. And then that kind of will bring up new questions for us that then we can move on to advancing foundational AI technologies. So I think I might have gone a little bit over, and I'm sorry about that, but to see if there's any questions either in the chat or people can unmute and just ask questions as well.
I can kick us off with questions. Thank you so much. This has been super, super interesting. One thing that I'm wondering, as you've talked about, especially with the image generation, these kind of iterative cycles of development, I'm wondering what has surprised you most about the capabilities and maybe the limitations of the software that you're working with?
Yeah, so one is that it's surprising is how fast it is improving, I would say. And so we started a year ago I started using AI generated images a year ago in another project, just because we had an artist who was drawing our pictures, but they're people and they're slow and they get busy. And so we thought, well, we have to go out right now and start doing our data collection. Let's start using AI generated images. And they were not great. And so now, like, the technology is improving very, very quickly. And so that's one thing that surprises me. I think that there are certain things that are surprisingly difficult to get the image generation to do. So we had a lot of difficulty with creating images that were like half full, like either one something to be full or not full. And for some reason that interpretation was difficult, and that's kind of surprising. I think the other thing that really surprises me is, like I said, about how good the images appear at first and how like we are just like good at ignoring a whole bunch of mistakes, right? Like it looks pretty good at first, and then you're like, wait a second, like there's a glitch here, and like what's going on over there, right? And so I think that it's both surprising how good it is, and also like the types of errors and the fact that we kind of just ignore those errors unless you really look at them.
Awesome. Thank you. Do we have any other questions from the group here? You also, if you're a little nervous about unmuting, you can feel free to go ahead and drop it in the chat and I can read it out so the recording gets.
So I got a note that it would be all right to unmute and explain my question in the question section.
Mm-hmm.
The question I asked was about bridging the gap between formal and informal education, but it was in the context of being a classroom science teacher who is now an informal education volunteer. So that's where my question came from. I was trying to say that the group I'm working with has to work with students to do some pretty complex presentations about robotics. It's a lot of science and engineering talk, technology. It's very relevant to formal education. The standards in science classrooms across New York State emphasize science and engineering practices, but sometimes the kids don't express themselves as they're doing fabulous things. They're making robots that I would never be able to do, but they don't know how to talk about what they're doing. So I said, well, I can help with that. I can't make a robot, but I definitely have 50 years experience helping kids talk and recognize science and engineering practice when they see one. So I started using, I was trying to create a permanent record that met the criteria of the judging they have judging criteria for this award they're going for. And I was going to use that as the framework for every conversation I had with the students so that they would be able to respond to the judges from practice, from just recognizing that they're already smarter than they think they are. So I chose this AI project, and I was trying to ask the question if you thought, based on your experience, if I was on the right track with it, and if I should be doing something else, or I don't know.
And you were using like an automated speech recognition tool to transcribe what the students are saying and then analyze it for the criteria.
Yeah. I was surprised. I used Otter AI 2 times just as practice with the kids. I said, I don't know what I'm doing. Just talk to me. And then I spoke their answers into the app when I got it. And when it was all done, it summarized the discussion. And it gave us a list of action. And I was laughing because one of the suggested actions was my idea. That was the reason I was even doing it. And I'm like, oh my God, the AI figured that out faster than I did, is what the kids should be doing in order to prepare for the award. It was pretty interesting. There were a few errors, but I think it was mostly my problem because I'm not that familiar with the app and I'm just learning. And sometimes they confuse the student with me, and I don't
Mm,
put the right indicators in the
mhm,
conversation. I have a lot to learn, but
mhm.
I think it's an interesting way. It's almost like people say, keep every time I talk to anybody. Now you got to be careful here because I'm 80. So I talk to a lot of people and they say, oh, now the kids don't even have to do their work. They don't have to do their own work. They just do AI. And I'm like, no, 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 that isn't
Right.
what's happening. Like these kids already have done a tremendous amount of work, and they're using AI to organize their thinking to go on somewhere else. They don't know it. I don't know it yet. We're just learning how to do it. But I absolutely can see it as a tool.
Yeah.
And I just want to make sure I'm using it the right way, or if there's other people who have done this and could give me some advice.
Yeah, I
So,
mean, I think that those the automated speech recognition tools that we have for adults are pretty good. They're really good.
mhm,
And so it's always surprising like how good they are, but they are very good for adults. I will say that because I work with kids, the automated speech recognition with children is really different. It's much worse. But we are making progress in that. I think that the idea of having a way of uh, categorizing and helping to reflect back to students like what it was that they said, because a lot of times like you give a presentation and it's just kind of like gone, right? Especially with like with oral language you speak and then it's kind of just in the air, right? And so
mhm,
having a transcript of it can help them a lot for preparing. I think you're definitely on the right track with the idea of using AI as a tool for being able to meet the pedagogical goals that you have, right? And so you
right,
have goals for what it is that they are trying to do, and then you're just using that as a way of helping them get there, as rather than being a substitute. I think is the absolute correct way to go about doing that. I will say that there are. I didn't say that we are the National AI Institute for Exceptional Education, but there are 25 other AI institutes nationally, and they're all on different topics. So there's like some in like forestry, and like they're like really different topics. There's 5 of the institutes that are focused on education, and one of them they came to Buffalo this spring, and we had kind of like a demo day. And one of them showed. I'm trying to remember which one it was. I think I can remember. And but they were showing this demo of something that's not really like available yet. But what they were doing was they had automated speech recognition that was kind of running in the background with students as they were doing a science learning activity. So they were actually building like little robots for self-driving cars. They had this little like track that they went around and they had to build the circuits and stuff like that. And then the automated speech recognition was kind of running in the background, but it wasn't just giving a transcript of what they said, but it was actually like the group had established kind of like community norms ahead of time. And sometimes these things, I'm not sure, they didn't have as much flexibility as I think maybe they were like, they had to fit certain categories, as if that makes sense. But they
okay,
had kind of community norms for like when people would say, show agreement with others or let another person talk in the group, right? Because they're all group based activities. And then it created a visualization of the group as a whole, which was like a tree. And so anytime you had somebody who like maybe I'm trying to remember the exact examples, but they would things like if you would invite somebody else into the conversation, right? That was a
mm,
category of things. And when you did that, then a certain type of leaf would appear on your tree. And so with that, the goal was to get students talking about science and collaborating on this topic of science learning, but also as a way of helping them with their like group work skills.
right,
And I thought that
right,
was really great because I think that that's a way in which it's not just a like a simple like transcript of it, but a way of saying like, hey, our goal, we know that students need to be able to work in groups, right? They need to be able to collaborate with each other and have some of these kind of like pro-social skills. And so having that goal in mind then led them to this idea of creating like a tree, and students got like they wanted to create, they got points for how good their tree was, but they didn't incentivize them like you have to say certain types of things, right? Because then people would just kind of like game the system and say those types of things.
Right.
But it was much broader than that, and I think that that's again another example of saying like, well, what from the beginning is our goal, and how can we use this to be able to meet that goal.
The group that is running this is called First Challenge, and they have community standards. They put it under one headline called Gracious Professionalism. And so that might, that might inform any kind of discussion you set up like that. But
yeah.
But do you know who these people are?
I'm trying to remember which one it was. So they were at the University of Colorado.
Sounds like just what we're trying to get done here.
Yeah. Remember the name. All the institutes have like different names. Okay, yeah. So they're called ISTAT. I can put it in the chat too. But this is the group that was working on it, and they were just doing a demo. So I don't know exactly the current state of their work. But they're looking at classroom learning in like general education kind of things. But that's another one of the AI institutes.
Yeah, that's interesting. Can you email me that? I didn't get it right when you flashed it up.
Sure. Yeah.
Do you have my email?
I think Carly does, because
yeah, I think Carly.
I'll get it to you.
Okay.
Yeah.
Awesome. Well, thank you so much, Allison. This was absolutely fantastic, and thank you all for being here. I know we're just about at time, but if you have any other questions for Allison or for our other presenters through the series, please feel free to email me. I'll drop my email in the chat now, and we will let you all go enjoy your Tuesday evening. Thanks so much again, Allison.
Thank you.
Thank you
for coming.